Hello everyone, and thank you for joining us today. My name is Rita, and I'm here with my teammates Scout, Christian, and Allie. Motions is a motion capture application that allows users to record themselves performing an action, then view that action in 360 degrees. We use the Microsoft Kinect SDK to collect users' skeletal data, then fed that data into Unity, where we mapped 3D models onto the data as it moved.
The first step of this process was getting the skeletal data from Kinect into Unity. To produce the skeletal data of a person in the Kinect's field of view, we use Microsoft skeletal tracking. This uses the infrared camera from the Kinect to construct a depth map. It then uses machine learning to compare this depth map to over 100,000 depth maps of known skeletons. We also created character bodies in Blender to give our skeleton a more lifelike look and to give users options for how they wish their captured motions to look. And here we have our 3 models. One issue we encountered with this task was that the Kinect data does not contain any orientation information. It only contains joints and then, by inference, the connections between the joints, or bones. Making the bones within our models point in the correct direction proved to be a difficult task, as you can see in this and the example that's coming up right after it there. To solve this issue, we calculated the unit directional vector between 2 successive joints, for example, a wrist and an elbow, and then took the appropriate bone and aligned its main axis along that vector. As you can see, this resulted in a much more human and physically reasonable movement.
While the Kinect sensor was sufficient to capture the motion data, our web application would not have access to the Kinect sensor. We needed a way to capture and preserve this data, to play it back and view it in 360 degrees in our web application. To solve this issue, we implemented XML serialization and deserialization to easily store the skeletal data in a file that we can read and write. Our XML file stores each frame of captured motion. Each frame contains information on every body tracked with all joint positions. Since XML was designed to store and transport data, it was a nice solution to implement. In the future iterations of motions, we would like to switch our file stream from XML to binary in order to optimize memory storage.
Overall, this project allowed us to explore a set of completely new technologies that we had never encountered before. It gave us a taste of Unity, which I think we all really liked and were interested in exploring further. In the future, we plan to implement virtual reality capabilities so that a user can actually walk around the 3D model of themselves. There are many possible use cases for a fully realized version of our application, including sports analysis, for example, perfecting a yoga posture or improving a softball swing, physical therapy, or even immersive gaming in which a user could move and interact with virtual objects. Thank you.